Okay, so what we did here today was we had to replicate this pendulum setup. We had to measure the distance between the chairs, the length of the string, the distance between the two pendulums according to the center of this one string. So we replicated our own here, and what we had to do was add our own variable. The variable we chose to add was adding a pendulum in the middle. When you started swinging the pendulum, we noticed that the energy did transfer over to both pendulums equally and then back across to the original pendulum. The types of things you can teach with this are periods and frequencies. You can teach procedures, scientific methods, measurements, energy transformation. You can teach them how to interpret data as well as independent and dependent variables. Okay, the next experiment we did were these skimmers. We just used cardstock paper, glue, scissors, and a ruler here and a pencil. We followed directions. We had to accurately measure it to get the little skimmer here. Once we got it built, we put it on our little launching device here. It's got a little rubber band. Just pulled it back and sent it. Both of them were pretty accurate. They went a long way, no problems. Some of the things you can teach from this experiment, you can teach kids about speed, velocity, measurements, about measurement conversions, and the importance of accurate measuring, because if we had measured these right, they would have gone everywhere. You can also add and subtract variables from these once you've tested them to modify them, make a more efficient skimmer.
And this one again is vinegar and alcohol.
Yeah. Vinegar, yeah. I'm ready. I'm recording it right now.
Man, that went way up there.
Yeah, it's about 8 feet higher in the building, isn't it? It's crazy, man. You ready?
In this lab, we were able to create rockets with chemical reaction basically inside of the container with the lid. So we put our solid substance here, our liquid substance here, we closed the lid and we turned it upside down and we waited for the reaction time, and it eventually shot up, and then with that information we could calculate the distance that it traveled, and we were using Newton's laws, chemical reaction ratios. We could collect data, use scientific method, calculate reaction time and projectiles. Hi, in this lab we use these materials to calculate the frequency, the wavelength, the amplitude, and by doing this we're able to teach vocabulary, how to do measurements, and you can calculate wave speed and conversions. This also engages people with multiple learning modalities.
Ooh, I think it was about right there. So there's 10 rubber bands.
Okay, so this is 10 rubber bands trial 2, and we are recording.
Get ready here. Whee! I still say it's about right there.
Still there.
Alright, so we're going to do 207 plus.
Okay, now we are testing 14 rubber bands.
14 rubber bands.
All right. 1, 2, 3.
No, I need that again. She was out of my camera range. Now I know she.
On the 15th rubber band.
Oh, yeah. It was underneath the notebook. Sorry. Wind's like blowing it around here.
I'm not ready.
I told Tia this is the most fun I've had with Barbies.
Okay, I am ready.
All right. There's 15 rubber bands.
15 rubber bands. Bungee jumping Barbie.
1, 2, 3. Ooh, she almost hit the ground.
She went way down.
So you just saw we did our Barbie bungee jump. We used Barbie dolls, 5 to 15 rubber bands, measuring tape, or some type of meter stick. What we did in our particular experiment, we used 5 rubber bands and 10 rubber bands and 15 rubber bands. We did them in increments of 3 and then took an average to get these 3 points you see here. With this type of a lab, you can use both math and physics. You can teach measurements, collecting data, creating and comparing charts and graphs. They might have measured theirs different, so we can see how their chart compared to ours. You can also teach like laws of gravity if you use 2 different masses and drop them to see how fast it takes to drop. They should drop at the same time in a perfect world. Some other things, different ways of measuring. They might have measured from the bottom up. On our particular one, we measured from the top down. And you can also incorporate data charts to organize your information in a different way.
Are you taking it?
Go.
Okay, so today we made ice cream. We used a couple of bags, sugar, ice cream, salt, milk, heavy whipping cream, and of course ice. We put it in bags and we all tested various ways of kneading it. They gently kneaded it, they rolled theirs, and we threw ours. That's why our hands are red. In the end result, we got really, really good tasting ice cream. With this, you can teach mixtures, chemical reactions, measurements, things like that.
Perfect.
Hi, we did this activity today and we used the Spark machine it had a lab on it, told us our tools, and it had some background information, and we were able to use that, and the experiment was to sit down at rest, measure your heart rate, and then do some physical activity and measure your heart rate. You were able to conduct a graph on here, and then we were able to with that, using all those tools, we could teach and interpret the graphs, and we could do calculations, and we can teach the importance of physical activity and how to improve your overall cardiac health.
Okay, here is our roller coaster.
I had a little surprise show up, and I'm playing that now.
And we got it to stop before our little line here. If it had kept going, all of our patrons would have fallen to their death.
Yes.
Tragic.
Oh, wow. I can pause.
Ready, set, go.
Still fast.
It's impossible.
In this lab, we created a roller coaster with pipe installation, masking tape, and we used a marble. We had certain specifications that we had to meet, camel's back and a loop. In this lab, we could use it in math and physics by using measurements, calculating speed and velocity, teaching about depressions and elevations, how they affect engineering, importance of angles, group cooperation skills, and how gravity affects structures.